Well, to end this section, let's go ahead and talk about example number 4. I want to find now the equation of a tangent line to a curve defined by y equals e to the x over 1 plus x squared. And I want to find that tangent line at x equals 1. Now again, I have no idea what this curve looks like. It's not even necessarily important, but I can go ahead and just pretend maybe I get a curve that looks something like this, right? And I'm going to go ahead and try to build a tangent line over when x is the number 1, right? So maybe it's like right here, boom, this is the equation of my tangent, or that's the picture of my tangent line. Now again, this is a mock picture, so I don't know if this is exactly what what my tangent line looks like, but it might help me at least structure my thought process. This is what I'm trying to do, trying to find the equation of that blue line. So I know that I'm going to need two things in order to create the equation of this line. I'm definitely going to need a point on the line, and I'm going to need the slope of that line. Well, I'm going to start here by just trying to calculate the point. In order to get this point, notice I'm going to need an x-coordinate and a y-coordinate. Now I already have the x-coordinate, I have 1, but how in the world am I going to find the corresponding y-coordinate for this? Well, that's actually a silly question. It's super easy. If I want to find the y, why not use the formula that says if you give me an x, I'll spit back the matching y. So notice if I plug in the value of 1 here, I'm going to get an ugly y. I'm going to get e divided by 2. Now keep in mind, this is an exact value. It's not rounded, so I want to use that exact value. Okay, now to find the slope, I know that I'm going to go ahead and actually need to calculate my derivative here. So I can say that we calculate y prime, and I'm going to have to use my quotient rule here. So let's see. 1 plus x squared is going to start on the top. It's also going to start on the bottom, and I'm going to use the rest of the top as like a product rule. So I'll start by taking the derivative of e to the x, then I just have to do a subtraction, leave e to the x alone, and take the derivative of 1 plus x squared, which is just going to be, oops, not x squared, 2x. Okay, so now that I have this derivative, I just need to go ahead and state that if I want to find my slope, I just need to go to my derivative and plug in the value of x where I'm trying to make the tangent line. So I'm going to go to my derivative and I'm going to plug in 1 for all the x's. So that's going to get me 1 plus 1 squared, e to the 1 minus e to the 1 times 2 times 1, all over 1 plus 1 squared. All right, so let's simplify this out here. Notice this is going to be 2 to the e, or 2 times e, minus 2 times e, all divided by 2. That's really just going to be 0 divided by 2. And so, oh, it looks like here the actual slope of my line is 0. All right, well, I have a slope, I have a point, and so I should be able to write out the equation of my line. Equation of the tangent. So I'll use my point slope form. I'm going to do y minus my y-coordinate, which is this ugly e over 2. Let me just write that a little bit neater. And then that's going to be equal to slope times x minus 1. Well, notice that this entire side over here is really just going to turn into 0. And so I'm going to end up with that y is just going to be equal to e over 2. So there it is. There's the equation of my blue line. Now, of course, it doesn't look anything like the line in this picture because this was just a mock picture to help me think about what I was trying to shoot for. So notice that I'm just using the same process and the same techniques that we've been doing over the past several sections to find equations of tangent lines. Nothing there has changed, except in this sense, I now have a different derivative rule to help me deal with more complicated functions. Now it's the case that we've actually seen so far a whole bunch of different derivative rules. They're summarized here at the end of this section, but of course you can also go ahead and take a look at the differentiation rules handout that, remember, is located underneath the Exam 2 materials folder. So far we've covered from the constant rule all the way down to the quotient rule. And we have a lot more derivative rules left to go. If you even just kind of glance ahead, we have many more derivative rules to go. There's an entire other page to this. So again, don't get too overwhelmed by the rules that are yet to come. We'll tackle those. We'll make them hopefully fairly easy to remember. But right now, we just want to focus on using the quotient rule, the product rule, and the ones that have come before. And of course, the best ways to do that, as always, are to take a look at those worksheets worksheets. So go to those worksheets, really try to practice these ideas, make sure that you feel really solid on them. That way, as we continue to learn more rules, you'll won't feel like you're falling or lagging behind. Of course, if you have any questions, please by all means feel free to let me know.